Okay, hi everyone. Thank you so much for joining us today for this conference on design in manufacturing and how design can be used to spur innovation. Um, so as you probably know, this is a 2-day event. So today is the conference, and then tomorrow we have a workshop. Um, and this is Nicolas. He'll be our main speaker. He's the director of Meaningful Studio in Paris. Um, and after that, we will have a client testimonial from Chris Farver, who is the Global Director of Controls and Information at Heat and Control, which is an engineering and manufacturing firm that does many things around the world, and its headquarters are in San Francisco. And the guests that we have today are Chris Baron, who is a Senior Director of Engineering at Agile Personal Care, Mark Durbano, who is an automation manager at Agile Personal Care. And Agile is a global company with more than 25 market-leading brands in shave, grooming, sun, skin, and feminine care, headquartered in Shelton, Connecticut. Then we have Raquel Bowling, who is a talent and training lead at the Connecticut Center for Advanced Technology. And the Connecticut Center for Advanced Technology is an applied technology demonstration and training center that validates, demonstrates, and encourages the adoption of leading edge technologies. Then we have Steve Bartlett, who is the Director of Engineering at Medtronic. And Louise Gratero, who is the Engineering Program Manager at Medtronic. And Medtronic is a global healthcare technology leader. And last but not least, we have Louise LJ, who is a research and development engineer at Verify, and Walter Sims, who is a product developer at Verify. And Verify specializes in customizable digital technology solutions tailored for ready-mix concrete producers. So now I'm gonna leave it to our main speaker, Nicolas, who is gonna tell us a little bit more about what he does. And actually, sorry, before that, sorry. Uh, so now each of our professional guests can give a little brief introduction about themselves and what they hope to get out of this conference, and then I'll pass it over to Nicolas. Yeah.
Check. Hi, I'm Walter Sims. I'm a product developer for Verify at Saint Gobain. We focus on digitizing the production, management, and delivery of ready-mix concrete. And what I'm excited to learn today is I want to get a deeper understanding of UX and UI, especially as it relates to industrial settings. And I want to be able to, identify opportunities for improvement and to better articulate those, opportunities to, leadership, the rest of our product team, as well as development. So I'm really excited to be here. Thanks for having me.
Hi, LJ Cox with Verify as well. I won't spare y'all the rest of everything there. Product development on the hardware side of things, and looking forward to this conference and workshop to collaborate with other people in other industries and figure out what's working there and what's not working so that we can all better the technology and the use of UX and UI.
I'm Chris Farver with Heat and Control. And if any of you guys eat potato chips, Doritos, Cheetos, and if you're into the new flaming hot flavors, they can't make them enough. Our company makes the equipment those things are made on. And one of the biggest challenges that we have is our workforce works about 3 to 6 weeks and then they're gone. It's just a constantly turning over workforce. So our graphics, our designs for our screens and how things run, you've got to basically take somebody that just left working at McDonald's and Chick-fil-A and turn them into a fryer expert in a week. So we have to build our controls to accommodate them. And I'm just the biggest fan of this guy right here because he helped us, I think, take a giant leap forward in those steps. So I'm here because of my friend here, Nicholas, and we've got some challenges in our industry, and I can't wait for the workshop because it's your creative minds that are taking us to the next step. It's not, if you let an engineer go build a screen, I'm going to get a nuclear power plant. You know what I mean? So this cutting edge where we're going right now, we're excited about it, and you guys are going to help us with that, I think.
Good afternoon, Chris Barone, Edgewell Personal Care. We make consumer products, make razor blades, we make fem care products, we do sun care products. We have a bunch of third-party businesses that we bought, online businesses as well, that we've actually become suppliers to. I run their engineering area. Mark and I work together primarily on advanced engineering solutions, trying to set up how we reduce similar situations that you have, Chris, where we're trying to eliminate direct labor wherever possible because it's changing so fast. People come in, they leave, and then we're kind of behind the eight ball. So a lot of what we're doing is we're bringing up a lot of systems now and trying to make it a little bit more user friendly and less labor intensive. So.
Mark Turbano, also with Edgewell, like Chris said, the interface with machines and how it can streamline the process, reduce training, increase uptime of the machines is vitally important and save labor along the way.
Hi, everyone. My name is Raquel Bowling. I work at the Connecticut Center for Advanced Technology, which some of you may have heard. It's also called CCAT. I am the talent and training lead there, where we focus primarily on developing curriculum for digital design, digital manufacturing, as well as quality assurance. And today I'm mostly looking to, get more feedback and more perspective on digital transformation and how we can keep implementing that into the future to secure a sustainable future in manufacturing.
All right, good afternoon. My name is Luis Valdera. I am coming from Medtronic. I have, like maybe 18 years working there, different roles from engineering, project engineering, manufacturing, production manager. Right now, I am in the role of program manager for engineering. And we are trying to, we are right now on the process of digital transformation where we are working with MES. MES is basically like a manufacturing execution software or methodology that is almost to get into the industry 4.0, where we have in the shop floor a mix of automated equipment, but also we have paperwork. And we are right now getting rid of paperwork and go all digital. So people in the shop floor will be using not just computer, but they will be using tablets to interact with equipment. So that's where actually we are getting into it. What I would like to get from here is more, maybe workshop related to how can we utilize digital transformation and connectivity with doing preventive maintenance. So, how to be ahead of the game and not waiting for an equipment to break down and then react. So those type of things is that we would like to kind of get into it. All right. Thank you.
Thank you very much. Thank you for your presence here. So maybe before to present myself, some dedication to Grace Hopper. We are talking about digital transformation and innovation, especially. And if there is a great people from Yale, it's definitely Grace Hopper. And it's also a dedication to Kalina, who organized that workshop. And thank you, Kalina, Grace Hopper, that kind of people. It's very difficult to say no to Kalina. And I think, for those who are friends, you see what I mean. There is another thing that is important is that today technology is a very male thing, but actually Grace Hopper literally invented the compiler. For those who don't know what is a compiler, it's very, very important part of the software, a very, very low level part of the software. And when she actually made it, she told her male colleagues, and they said that wasn't possible. But it did exist. So it's also very inspiring in terms of what we are trying to do, because actually digital transformation is not easy. It's not easy at all. The other dedication I would like to make is for ET, for Edward Tufte, which is a very, very well-known statistician, but also maybe one of my great inspiration in terms of information design. He literally invented the data information visualization in the maybe in the 80s, and actually he was a professor here. So now I can maybe more introduce myself. So like Kalina was saying, I am a digital designer. I'm also a teacher in France in the digital school. I am a speaker. Because I have 4 children, I think I can say that I'm a child breeder, not only a father, you know. I am also a guitarist. One of a good friend of me told me that I was actually a pragmatic poet. So today I will talk much more about the pragmatic side, not so much about the poet side. But first, I am a guitarist. I am a rocker, basically, and I love this quote from a very, very famous graphic designer in the US. So you have an understanding of finally what I want to do in my life. What is my mission? Okay, I want to save the world. I couldn't do with rock and roll. Okay, I will try to do it with design. So talking about designers, so in the US, it's a bit different than in France, actually, because in France, design is a part of the art. You know, they are much more in the architecture, and design in the US is much more in the engineering part. But still, for there is still, let's say, a truth, which is, as a designer, you have to work both on the rational way of thinking. You know, it's very methodic, but also on the creative part, the intuitive part. And in order to be creative, and this is my let's say my conclusion about 10 years of teaching design, is that there is only one question as designers you have to answer, is which designer are you? Which means, who are you? Because you cannot create, you cannot, you know, take this intuitive part if you don't have a clue on who you are. You know, you start from yourself when you relate on your intuition. This is why, at least for me, there is not such things as design. You know, there are only designers because of that. You know, we are methodic. You know, we are pragmatic, but we are also very, let's say, we try to understand ourselves in order to be able to solve very, very difficult problem. Talking about the industry. So the situation here. So it's just example of, you know, just a simple request on Google for let's say HMI or SCADA systems, which are basically what the operator have. You know, when Chris was saying, okay, we have people that are working for what, 8 weeks. They have that kind of, you know, interface. You know, you have all smartphones, or you go to the McDonald's and you can order very, very easily. So you basically don't learn it. It's not completely true, but still, it's easy to use. But this is the reality of the factories, and maybe 90% of the factory, or maybe 95%. And this is the starting point. So, like you said, maybe we can try to do better, you know, and this is what is about digital transformation, you know, MES and so on. So, okay, this is the starting point. So now, okay, let's try it. Let's try to do it better. So maybe trying to make things right, or maybe beautiful. But there is a problem. Typically, it ends in failure. It's because it's very hard, you know, MES project. Generally, when we come in MES project, there has been maybe 3 to 4 attempts before us, you know. because it's very, very hard, digitalizing. There is paper today, and then you try to put it on the screen, and then suddenly doesn't work. People don't want to use it. They don't understand. The accuracy of the information is not so great. So this is what I will try to do, is to present you some, let's say, example and maybe some what I use in my daily life in order to deliver those projects. So I will take a step back and trying to share with you some, let's say, how I deal with that thing. So first, my let's say background is much more in the information, let's say, side. So maybe what we can do is to just have a reminder of what was the purpose of digital technology. And I could make an entire course for a week about just that topic. So I will just try to make it very quick. But one thing very, very important that we tend all to forget when we are talking about digital is the very, very, let's say, foundation of what is digital, or what was the objective. So one of the great, let's say, inventor was Norbert Wiener in the 50s. And basically what he tried to do is to, let's say, engineer the feedback, the concept of feedback. And generally when those digital products, they fail, MES and so on, is because the feedback is not completely, let's say, integrated, but it's very, very a core aspect of the digital. If you don't, it's a great opportunity, basically, to go along that feedback. And I will, of course, give you examples. So feedback, very, very important. And I have put at the end of this presentation bibliography for the few books I'll share with you. There is another aspect, and maybe at the end of this talk, we can discuss, and we can discuss not only about digitalization of industry, we can also discuss about just digital, and how it affects our society. I know that in the US, you like very much the French philosophers, especially those of the 60s and the 70s, Deleuze, Guattari, Foucault. Actually, you prefer those philosophers than in France. In France, we dislike it, at least the student, and the professor dislike it. But and maybe so Gilbert Simondon was a friend of Deleuze, actually. And he wrote a thesis about the nature of technical objects. And he says something very, at least for me, very important, that explains a lot about how we collectively deal with technology. Is that he said that if we don't properly understand the nature of technology and machines, then there will be an effect on the society, which is both sacredness and rejection. And we see a lot, you open the newspaper and you see that, okay, TikTok is very dangerous for kids. So this is definitely rejection. And on the other side, you look at, I don't know, startups in San Francisco, OpenAI, for example, or they can have $1 trillion, to build factories, in both ways. And general AI will happen. This is completely false, but it's very, very interesting to see that somehow. And Gilbert Simondon was writing in the 60s. He failed, we collectively failed, to learn the nature of technology. Because if we truly understood the nature of technology, then we won't be in that situation. And actually, Gilbert Simondon also wrote a course of technology, which is absolutely beautiful. I don't know if it's translated, it has been translated in English, but in France, it exists. It's a very, very beautiful text. The other aspect, so there is another aspect that in the industry is very difficult to shift from, let's say, equipment to digital, or in industry 4.0 is very hard. It's because of the cultural aspect. Like you said, Chris, when you look at that kind of screens, here it's a command and control. In order to do that, you can do a lot of things. Basically, you can do whatever you want with the machine. But it means that you are controlling that machine. You know everything about that machine. You are that kind of masters. But this is not actually the case in what you try all to do in terms of digital. What you try to do is to shift to command and control, to being in charge, actually, you know, and this is completely different. So you can be in charge without controlling, basically, or at least so directly. There is an important aspect. This is something that I saw from a banker, a French banker, that explained his point of view on the, you know, the difference between the physical world and the informational world. And I think it's really explain a lot of the difficulties that industrial face when they try to, let's say, integrate this informational world. Industry, it's about a physical world. You know, it's very tangible. When you go in a factory, you cannot cheat. You know, you cannot say that something is not happening if it is happening. You know, you are dealing with material, physical material, and so on. We are talking about fixed standard. This is quite interesting. You know, we are talking about cubic meters, inches, and those are standards in the entire world. A meter is a meter. It's always a same meter. We are talking about also finished product. You know, when you finish, when you deliver the potato chips, you know, you cannot alter it. You cannot redo it. It's finished. And of course, we are talking about the physical aspect of things, especially when we are talking about machines that replace operators, you know, the physical things. But when we are talking about digital, it's a completely different universe. At the origin, it was to help the mind and not the body. You know, the machine is here to replace the body, but the digital is here to help or replace the mind, which is completely different. There is no standards, you know, there is no fixed standards. The standards are evolving all day long. You know, if you take the capacity of your smartphone, you know, 10 years ago, you know, I don't know, 34 gigabytes. It was completely incredible, but nowadays it's nothing. So it's always evolving. So it's very hard, you know, for people from engineer, from industry that, you know, that know that a meter in 100 years, it will still be a meter. But in the informational world, what a gigabyte in 100 years, really? It is a nonsense. There is also the aspect that we are talking about infinite products. You know, when we are trying to make an MES, for example, you might think that, okay, it's like an equipment. You buy a fryer from Heat and Control, the fryer is installed. Okay, it's installed. It will work. And an MES, when it is installed, you know, it will evolve all the time. So it's infinite, very hard to tackle for you know, when you knew how to say, okay, I will ship that fryer because the fryer is finished. But a digital product, when it is finished, look at, don't know, TikTok or Facebook or whatever, it's changing every day. I think that Amazon is changing its code every 11 seconds. So it's a completely different way of dealing with projects. And of course, here, and this is something that we tend also all to forget, is the fact that digital is about decision-making. You know, it's, of course, we all have, let's say, a social network and so on, which is about entertainment. But at the origin, it wasn't at all about entertainment. The origin was about decision-making. And this is a very good tool in order to do that, but completely different than the physical aspect of things. Very, very quickly, I won't make a course about design, but there is one thing that I learned from my wife. I'm a self-taught, you know, and I literally married design. My wife is a great designer, and she's my boss also. And she's listening to me. So there is one thing that she understood of the design. Not every designer understood that, but it's very, very important in terms of project management. How to, you know, to, let's say, design things in this digital realm. Is the fact that if we look at what is informing, you know, giving information to something, actually, there is two way of doing it. You can, of course, use text. Yeah, language is by definition a way to convey information, but there is a problem. Language is very, very ambiguous. You know, the hallucination of OpenAI or any AI things, they are not hallucinations. You know, it's because the language is very ambiguous. If I'm talking about an ERP, and if I am asking every professional here, what is an ERP, you will all have a different answer. It's true also for MES. You know, I have, I don't know, maybe 20 clients, 20 different definitions of what is an MES. So words are very, very ambiguous. But form, when you give a form to something, whether it's a physical or digital, and I will show you an example, then you have a lot less ambiguity. So the capacity of design is to reduce the ambiguity and to go toward university. This is through that, let's say, aspect of the design or the byproduct of the design that we can align all together. Because, of course, when we are trying to make an MES or a digital product, the idea is to all have the same vision, you know, and design is very good for that, you know, because of that aspect. The other thing, of course, if I go back to the rejection or the sacralization of the machine, there is a third way, you know, just loving the machine. You know, I think that everybody here, at least those who I know, we love the machine, you know, and this is a good way, you know, to understand the machine and to deal with them and to build things with them. So no rejection, but no, these are just machine and equipment. Those are beautiful things. We should respect it and work with them. Third aspect, the people in the industry. So here we'll most talk about, you know, the people that are actually running the machine, so the operators, and on the other part, people that in the industry that are trying to make things running or trying to make factories and so on. What could design actually help with, and this is related to this university aspect, is the ownership. Because you have heard about silos in companies, you know, so silos are basically how the enterprise are organized. So for example, you have finance, I don't know, marketing, sales, engineering, R&D, or whatever. The problem is that when you are trying to do that kind of product you are talking about, there are some aspects that are between those silos. And the work we've done with Heat and Control was exactly that case. You know, when we are talking about procedures, and I will talk about that, this is not the responsibility of any people, you know, and this is why, at least from my point of view, why a lot of projects are failing because of that. And this is why ownership is very key, because if you try to make something transverse, somebody needs to take that ownership, even temporarily. This is the only way to go through, in fact, that kind of product. At the end, you can give the product to one of the part of the silo, but still, it's a problem. I won't talk, I will just give you some example of real life case studies. I won't talk about maintainers. I would just say at the end, I would just share my feeling about maintenance and sustainability regarding industry. Today we will much talk about factory managers, line manager, machine operators, people that are very, very, let's say, grounded into factories. I won't talk about business unit manager or world company manager, but still everybody, this is everybody that is involved in digital transformation. Normally, everybody should have the same screens, you know, and share the same reality because this is the same factories and the same assets. Like you said, Chris, the prime is the know-how. And this is not only true for operators that last for 8 weeks, you know, or 8 months. No, 8 weeks, sorry. It's true for everybody because of the boomers. Boomers are leaving they are going to retirement in the entire accidents. And they knew how to run things. And we are losing know-how every day in every factory in the entire Occidental world. I think it will be true for China in the future years because they have also that problem. This is the key aspect. There is no other aspect, actually. You know, this is the only problem that everybody is facing, or at least the main one. So how to deal with that know-how? I will now give you 3 examples. The first one is a very, very basic one. You know, it's unloading trucks in water treatment facilities. This is the interface that the operators have today. You know, buttons, no manual. So here you can see that, and I'm talking about unloading dangerous products, you know, hazardous product. And here, this is what we could design, what we can do actually. And this is a real life example. So let's go here, for example. Here, there is a lot of principle that should be applied in every factory, in every, let's say, screens. Those are principles that are very, very simple and basic. You know, first one is feedback. Like I said, you know, for every step, you have a feedback, or the operators has a feedback on what it is doing. Second, the context. Here, an operator can use that interface and unload very, very dangerous product in less than 5 minutes. You know, if of course, if he's capable of. No, not everybody is capable of doing that kind of things. So you have the context on where to unload, the quantity that are available in the tanks, the quantity in the vehicle, the people that are in charge, the organization of, let's say, the system, and where is the product into that system, the documentation of all those different tasks, you know, and if the operator doesn't know how to use it, then there is a small video, so he can play it and have the information on what to do. This is especially true for one thing, and this is something that is related to cognition. There is a problem with the human, you know, when the human are stressed, they lose cognitive capacities. It has nothing to do with intelligence or IQ or that kind of things. If I'm yelling at somebody, he will lose cognitive capacities. And here we are talking about unloading very, very dangerous products. And when you do that, you put people at risk. You are yourself at risk, but also the population around. So definitely, you might be very intelligent. You won't be at full capacity in terms of reflection. And the problem is when there is actually a huge problem. And here, this is where it becomes interesting because, you know, okay, simple things to do. Let's say we can let's say live without it. But in case of a very, very big problem, here, the operator can follow, you know, just the procedure to be safe and to be safe himself, but also the entire company. This is a very, very, let's say, a good example of good practices. Here again, this is a matter of feedback. You know, there is a problem, you see the problem, but you see also the procedures that is related to that. At my knowledge, very, very few companies have that kind of systems because of the silos, because of what is the procedures. If I go in any factories today and I ask, can you give me the procedures for that? Nobody is able to do it. You know, because there was a procedure at some time, okay, it's in a Word file, Excel file, on some computers, on somebody. Maybe in 1 hour to, let's say, 1 week, you can have that procedures. In the reality, I mean, it's not very, very, let's say, industrial and engineered. and it works very well. The other example I wanted to share with you is a bit different. It's the same water treatment company. It's a very, very huge facility, 2,000 acres. So it's a very, very huge space. And again, about people, about how people can, let's say, react in front of very, very complex systems. When I take that huge factory, there is no manual, there is no driving wheel, there is nothing, you know, in order to pilot. There is only the screens that I showed at the beginning. You know, you see the equipment, but you don't have an overview on what is going on. You know, you don't have any clue on the global context. So in that situation, humans, what do they do? What do? We tell ourselves stories, collective stories on how things work. Actually, it's true for almost everything. You know, we don't understand how banking works. For example, we tell ourselves a story, and maybe in groups, you know. So what our work was to work with the actual operators of that huge factories and try to figure out what was the stories they were telling themselves. And like I said, yeah, the procedures, not only the procedures, but the overall context, how do they run that huge facility? It wasn't written anywhere. You know, it was the maybe 20 to 30 people that was running that facility or that part of the facility. They tell themselves a story about how to run that facility, that plant, but nobody had written it and not on the screen. So this is what we did actually. We put all the stories. Of course, we put also the technical aspect of things, and we put it on the screen. So now in 5 minutes, they can have an overview on what is going on, what is the next step to have, is the plant right or not, and of course by giving information about several contexts, like for example the level of the river, which is very important in that case. The reason why it works is because of that. You know, we were talking about MES and so on, and it's true for everything. One of the key, let's say, reason of the failure of the digital transformation in industry, it's because you ask engineers, and only engineers, they don't provide only, let's say, not very good screens. This is their point of view, which is, you know, they are in charge, they should know, and generally they say that if things are not properly going, it's because of the operator. And it's not going, the reality is not exactly that. Of course, there are the engineers, they know how to run properly. Of course, they are engineers. But at the end, there are people that are dealing with equipment and facilities all day long. They know how to run it. So generally, the digital transformation failed because, you know, you just ask engineers and you say, okay, operators will obey to that new things, and it doesn't work. Of course, if you do the opposite, it doesn't work either. You should, you know, have everybody in the same room, again, silos. And this is a good example of what I was saying. You know, if you are able to design that, this is very, you know, this is very easy to talk to an operator, an engineer, and everyone with that screen, because this is the same reality, and this is a reality that is, I would say, real, because it's coming from the actual use and the actual understanding. This is where there is an opportunity also, because maybe the operator are wrong, and you might be not completely right on the first step, but because it's evolutive, you know, you can go toward the right direction because you can change it, you know, and it's not like a physical thing anymore. For the third use case, I will ask Chris to come. and talk. And this is the basically this is the screen that they have today on the huge facility. You know, that kind of screens where there is a lot of more information that the screen that I showed. You know, this is the new screen. There is more information here than here, and this is much more legible. So maybe Chris, you want just to introduce Heat and Control briefly, and we can show the work that we did together, right?
Nice.
These are your slides.
Oh,
Just
okay.
if you want to
Yeah.
present very briefly Heat and Control.
Let me just say, real quick, that you guys, I'm really excited for you because the operators, you saw those slides, right? Those people are going. Those operators who understood how to understand those screens are moving on. If you bought an UTS potato chip, it was produced at a plant where the husband worked the fields and the wife worked the factory. She worked there for 45 years. The person that replaced her stayed for 6 weeks, and the next person stayed for 6 weeks. So we're losing, you mentioned that earlier, we're losing that subject matter expertise that knows how to run those lines. And we've got to be able to transition over. And let me just tell you, the next step in this whole digitalization process, I've got a tour with my team in 3 weeks. You know where we're going? We're going to Amazon. And the reason why we're going to Amazon is that I have a ton of customers who want me to gamify our OITs. They want to turn into games. So as a packer is packing potato chips into a case, and they're trying to move that efficiency over, if that feedback, to your point, needs to be a race car, we kind of make it like a race car. And what Amazon was able to achieve was a 15% increase in efficiency by gamifying their OIT, which I thought was fascinating. It's a whole new step into what we have to do. But with Heat and Control, we do the equipment that makes all those chips. And it came over the years in the 50s and the 1960s. A couple of men came together and they started to work in the process industry by heating up tanks, and they gravitated over to the food industry. And we created these vast big fryers that could do 5,000 pounds of chips an hour. And then those moved into distribution systems, and then customers, they would have to weigh this stuff. Well, when the Japanese stepped in at Ashita to create the circular scale, where we take fast calculations and add up how many chips are in each of those buckets. And from that, we make a dump, which makes the bag of chips. We put it in a bagger. We became Ashita's representative in North America. Then we added the product handling equipment to move all those chips around to get them to the packaging area. And we've added a bunch of companies since then, and we're 750 million globally. And we work with every snack food company in the world. So if you're over in France and Europe and Germany, we work with Intersnack. In the States, we work with Utz, Frito-Lay, Shears. We also make egg rolls too. And we do all the pre-cooked stuff that goes into Chili's. The same egg roll that's in some of the nicest restaurants and at Panda Express came from one factory. There's not a lot of creativity when it comes to egg rolls. Move forward. We're just a big company and we have a blast doing what we do. But we also, your generation, unlike my generation, when I got out, in 86, we just wanted to turn product out the door and then make a living and pay our bills and go on vacation. You have the opportunity to do more than that. You have the opportunity, you got to do that, it's baseline. But to kind of help our planet to a certain extent. You know, if you look at what we have in the way of the planet right now, 14% of the earth is fertile. That's it. And we have to help a lot of that percentage in order to do crops and to grow what turns out to be a potato chip. You look at when a potato chip is harvest, or potato, excuse me, is harvest, it loses at just the pulling and harvesting of it, it loses 20% of its content. And then as it moves to storage, we have to store potato chips because people like chips in January. In March, we get shrinkage, we lose 9%. And then when we get to the processing area, so we actually take that potato chip and start that potato, we start to trim it, and then we start to clean it, then we start to slice it, and we go into the fryer and do all that. We lose about 15% of it, and then as it comes to the potato chip out the door, we lose 7% of it. And by the time we get to 2% of that potato is there for consumption. I, as a manufacturer in that industry, have got to create better yield and use less product to make as much volume out the door. Your generation gets to address that. We're starting to now. So 29% reduction in food and snack manufacturing capacity is just getting tighter. You know, money's hard to get, so people need to be able to increase yield with what they have. You can tell where we're going with this, right? We got to be able to do more with less, and better graphics on our OITs, better, easier things. By the way, better to better beats better to best. Think about that. Better to better beats better to best. We've got to be able to make screens that help our operators improve every day. Customers' equipment's near end of life. Proportion of the workforce is set to retire 50% by 2025. That's where I'm getting at, that point where, you know, the older folks that know the systems are moving on. In our industry, we have a high turnover, 6 weeks to 5 months. You must train them while they're running the line. These very expensive assets that you have your company's DNA in is being run by somebody, like I said earlier, that just left McDonald's. You need to build screens that add value to their lives. You know, people want to do something they feel have value. They don't want to just come in and do the mundane thing every day. And like I said earlier, we're having to look at gamifying our screens. That's the big push for us right now, is to, you know, how can we make feedback to them closer to what they do on the weekends or in the evenings, and add value and improve efficiency. So that's us. And this guy did an amazing job with our screen.
I will share with you. So we just share some of the key some of the key screens that we designed with Chris, actually, in the Audis team. Interestingly, you see on the top an entire line of production. And here you have a good, finally, example of what are those silos. The silos are not just, let's say, management silos, finance, and so on. There are also silos in terms of product. You know, there is a team for the fryer, a team for the in-kitchen seasoning, one for the burner, completely different. They don't talk to each other because, you know, my equipment is different. So this mindset of my situation is different is literally the problem we have to solve, basically, how to make something that fits every need. And we have to find common ground for that. One of the things that we did is that we try to respect the fact that, like Chris said, there are trained operators in the field today, but they are new also. How do we deal with that? If we make something very, let's say, too easy to use for the old operators, trained ones, they will reject it because, you know, they will feel like child. On the other hand, how do we ensure that the new ones, the rookie, can actually use it? So we have, despite the fact that, of course, we have designed beautiful screens regarding the operation, we have introduced the guided mode concept, which is something that you have, you know, on Google or whatever. When you have a new version of it, you know, you have some kind of tutorials. So we have integrated directly tutorials that you can actually trigger. So You can, if you are a trained operator, you don't use it. If you are not, you can definitely use this guided mode. And then we designed all the screens with all the content of the different steps. So the operator can actually, follow what is at stake. You are saying, Chris, that the idea is how to make meaningful things, trying to help the operators to let's say have more meaning in their work. Training them live is something, helping them to understand what is going on. It's meaningful, because people want to understand what they are doing, basically. And if you think of your screens or your HMI as media screens, they are media. You can do a lot of things with media. You can control, but you can also learn, basically. So this is what we did, and the idea is to definitely have let's say engineered way of working with those screens. So here you have an example of the. I'm sorry, where is my? Yeah. You have one, let's say, equipment, but here we are looking at a completely different equipment. The look and feel is the same. We try, to be in the same, let's say, philosophy, so that, let's say, operator from one equipment can work on another equipment without having to relearn everything, because it's a different equipment. Okay, different way of dealing with it. It's not good for, let's say, HR. I would say. And here also example of what you do. One thing also that is, let's say, important in terms of how to properly, let's say, design interface that actually work, is to deal with alarms. This is a huge deal, actually. For the people that don't know industry, I showed you, screens where you can control, but if you are dealing with problems and alarms, you have a table, and that's all, basically. So you need to be trained for 30 years in order to know every alarm and how to deal with them. What we do here is common sense. When you have an alarm on an equipment, you see the alarm on an equipment. You don't see an alarm on a table. And this is common sense. And this is actually, a recommendation of the international norms that are not applied at all in the factories. There are a lot of norms that are not applied, actually. So this is also something that helps clearly to, let's say, leverage that design, let's say, aspect. Maybe before asking Chris and his feedback, I would just finish my presentation. If I find it, where is it? Because we have the chance of having. I don't know where is my presentation. Oui, le PDF.
Oh, je pense que tu l'as fait.
C'est ça?
Qui...
Non, c'est pas ça. Ouais. Ah oui, c'est ça. Thank you. Thank you very much. Chris, you were talking about the future. And a lot of industrial here, you were, let's say, curious about how to deal with digital transformation. So maybe before talking about process design, this is my understanding of 10 years of working in the field of industry and digitalization of industry. This is a design point of view. This is not a technical point of view. I figure out that there might be some kind of maturity model for the HMI or the interface, but that is also related to technical maturity. The first level, I would say the zero level of digital twin, because if we're talking about digital maturity now, the let's say the fashion term is digital twin. Digital twin is just the fact that you have, let's say, achieved the entire digitalization of all the data that you could gather in the factory, whether they are manual or automatic. The first screen that I showed to you, in the reality, this is level 0. You just have information about equipment. The feedback is very poor. You have only feedback from equipment, but running a factory is not about running equipment. Running a factory is about producing things and shipping things, which is not exactly only, dealing with PLCs, for example. The second level, which is for me the stage 1, is integration of the process. And the process are the example that I've shown, on, for example, MES. This is typically you put the process into the screen. So you have an idea of what you are producing actually. Is it good? Is it not? How many pieces do we have to produce? And so on. And this is the first level for me. The first stage, it's about MES, it's about traceability. So somehow what is going on into the factories. This is about production and this is about people, but this is just the first step. Because somehow you manage to put the information from the ERP and put it on the shop floor and having, let's say, a first aggregation of the two information. Basically, ERPs are information this is the systems that deals with clients' orders, basically customers' orders. An order takes an order and then it goes into a system, technical system, and this system is connected to the factories. And this is what we're talking when we are talking about MES. We have the shop floor with dedicated, let's say, interfaces that are not connected to the global, I would say, systems. First step. Second step is the example of fit and control. Second step is about dealing with procedures and helping operators to know what to do. And this is closely related to alarms for me, alarm management, because it's the same problem. If you're able to deal with your procedures, that means that you have dealt with your alarms. Because if you have just procedures when the sun is okay, it won't work in the real life. You need to deal with procedures when problems occurs. Hence, the alarms mastering, very hard to do. Very, very, very hard to master. Again, few, at least of our clients, are able to do that. Third stage, this is the complete, let's say, optimization and the complete digital twin, where you have everything. You have all the information from the PLCs, which run the equipment, the information of the process, meaning the production order and so on. And then you have the procedures. Then you might be able to send that to the cloud and run AI things, AI programs and so on. And then maybe you can connect back, you can get back to the PLCs in order to properly handle the PLC, because we are in a very strange world. Before going into factories, I thought that every company in the world was Amazon or Apple. People that manage so well their process. Everything is automated, everything is in control. But the reality is that it's not at all the case. We don't control anything. I work with energy in the energy sector. Okay, we don't control much actually. And if you look at everything that is there, there is little things that are really mastered. This is why we are at risk. This is why the retirement is a big problem, because we might think that we are all comfortable and that our world will continue as ever because we are mastering it, But this is not true. We are all at risk. We can lose big parts of our life just because we think that, you know. So there is an opportunity in terms of digital, but definitely it's not as simple. And especially for the equipment and the machine and the programs that are, let's say, dealing with machines. When you install a new machine, for example, a fryer, you know, you put a program in it and then you forget it. If you need to change anything, there is somebody that needs to come and make the change and try it and so on. Very expensive, very hard to do, and you need to have the right guy, which is very complicated. Maybe with the digital twin, maybe this could be, let's say, better handled. I'd say maybe. This is the promise. So this is my my point of view, and generally the project fails in the reality because everybody tried to go to stage 4 or stage 3 at the beginning. You know, okay, let's do a complete optimization and digital twins. No, you don't have foundations. It's like making a building without foundation. It won't work actually. And finally, maintenance and sustainability, like you said, Chris. This is a discussion that I had with Kevin, which is a partner of Chris. Why are we struggling with sustainability? Because we are not at all dealing with sustainability collectively. I mean, you know, what is at stake? There must be a huge problem, much more, let's say, important than just saying, okay, we need to be sustainable. Okay, but why aren't we able to do it? My take on it, my 2 cents. I don't know if you have heard about Simon Sinek. He's about my age. He's on LinkedIn. You know, he's a kind of guru. He's very good at speaking about others' ID. You know, but he has an audience, so it's interesting. And lately, he talked about a very important book. I put it in the bibliography, which is not there. And this is a book from James P. Cars. It's theologian. I don't know if theologians means something. No, he works in the. It's a philosopher, but let's say religious philosopher, religious scholar. And he wrote a book about the 2 types of game. There is the finite game and the infinite game. And the book is called Finite Game, Infinite Game. And it's very interesting because he's talking about the fact that if you look at, you know, all the games that we are playing precisely, we are playing finite games. What is a finite games? It's games where the idea is to finish it. Of course, there are clear rules, let's say fixed rules. And chess, for example, is a good example of that, but football also is a good example of that. And he's explaining that this is our cultural, let's say, way of dealing with the reality. And because the idea is to terminate things, the idea is to consume things, you know. And when you are looking at an operator, the operators need to produce things, so it needs to terminate objects. So you need to consume things, materials, for example, and to consume the machines also. But there is another game, let's say, type. It's the infinite game. And what are infinite games? Is that it's that game where the idea is not at all about winning and finishing. The idea of an infinite game is to stay in the game. This is the goal, you know, of an infinite game. And the idea, in order to do that, is to invent rules because this is infinite. So, and you need to stay in the game. And this is quite interesting because if you look at how industry are handled, but not only industry, a lot of things, you'd see that we are all in that finite games. We try to win all the time. But winning for us is a finishing. Maybe it could be interesting to continue winning, but not by finishing, by staying in the game. And the book that I've put in the biography, honestly, I recommend it to you. It's a very, very important book for a lot of people, all the people that have actually read it. It could change something, you know. And for me, when I look at industrials, when I look at my clients and I look at, okay, the maintenance guys, nobody cares about maintenance guys. It's really, really a problem, you know, when you are, and it's true everywhere, you know, and it's true on every aspect. Nobody cares about maintenance guy of that room, you know. We don't care about maintenance, but if we don't care about maintenance, we don't care about sustainability. This is the reality. This is my, you know, understanding. So if we want to, so here I gave some example of, you know, operators screens that actually works very well. But if we want now to deal with maintenance screens, we need to think completely differently. The goal of maintenance is not to win. The goal of maintenance is not at all to finish, to end the product. The goal of maintenance is completely different. So that means that the interface should be completely different, completely. And we need to think in a, I wouldn't say opposite way, you know, complement in a complement way. But the real issue is that from what I see, nobody cares about that. But maybe nobody cares because nobody understands how to deal with it. This is the, let's say, positive view on it. And to finish, Alain, you had the question about what is design. Honestly, I don't have any clue on what is design. I know what is a designer. And the title was, you know, UX, UI design, which is the, let's say, the fashion, or it was the fashion way of, let's say, presenting design today, which is designing screens, you know, screens and applications and so on. But I wonder if the work that we are doing is really UX, UI. You know, maybe what we are doing is much more that process design. We actually design process because when we work with Verify or with Hit and Control, you know, we put the process, we put it on the screen, but we literally design the process, you know, because it hasn't been written anywhere, or at least, you know, in a structured way. So maybe it's our form, you know, of design. So this is my conclusion. Thank you very much. Thank you for your attention.